Hi and a warm welcome back from me, Karl, with Wooden Data Center. Today on day 3 of our Wooden Data Innovation Week. Today I have something really exciting in store because this is not a modular data center as I'm usually designing and preparing, but this is like a proper facility, a hyperscale facility that pulls out all the stop, and it's quite a unique way of going about building really efficient data center and scope 3 optimized data centers. This will be just a short introduction of the module, which is the core design principle that we use for 100 megawatt hyperscaler. Each module, as you can see, is about 8 meters wide, has 2 stories of white space, and is can be continuously added, like module after module, to extend that. And we have a central hot aisle and left and right air filtration and cooling units that supply the first and the ground and the first floor with cooling air. There is a return feed of hot air over the top into the cooling units to mix in air. The really unique thing about this, and the core technology we designed this around, is superconductive busbar. Those are those blue tubes in here, which is like a tube-in-tube system that has the superconductive material, which is a very unique metal alloy that is running in liquid nitrogen. And we actually have 3 uses for this liquid nitrogen in the data center. The complete module houses in this setup 52 OCP rack version 2 in a single aisle containment, but it can be extended for HPC purposes also to higher workloads. But in this configuration, the each module holds about 1.3 to 1.5 megawatts. And the unique thing is that the superconductive busbars are DC, and we have direct connects to the rack, which I'll show quickly here on a data center on the OCP rack that Facebook released. You have the central busbar here with a ground and a positive busbar showing here, and this is directly connected with so-called tap-offs to the superconductive busbar, eliminating each and every power shelf. 100 megawatt data center without a single power shelf in the rack, resulting in a massive in a 30% higher density per rack. And by eliminating AC in the complete data center, we don't have AC DC rectifying, we don't have losses, we have a lossless busbar, we don't have losses in transport of energy, and we also don't have the power shelf itself, which is combined the last inefficiency standing within a data center, which is usually quite overlooked in the PUE analysis, and we have managed to build this out quite nicely. We will have deep dives in terms of technology videos on the CLT wooden construction coming on Friday. We will have a deep dive interviewing VESC Busbar, with whom I'm together developed this concept, and it was accepted in the Future Technology Initiative of the OCP. A video with Wolfgang and Victor from VESC-superbar on the busbars, and a video with Alan on the unique cooling solution he patented, using liquid nitrogen for cooling and for oxygen reduction in case of fire protective systems. Plus a video on COgeneration, because we can take massive amounts of cost out of the backup the backup technologies in a case of a COgeneration setup. Thanks so much. Looking forward to the next videos, and goodbye for now from me.